Fantastic. We're going to talk about the architecture of federation. We're going to spend the next 25 minutes or so. I promise it's not all talking in slides. First things first. My clicker's not working. Yep, OK. First things first, thank you. Some of us have traveled a long way. We're away from our friends, our family, maybe our kids and our parents. So if someone hasn't told you today, thank you for spending your time with us, investing your time. It doesn't go unnoticed, and part of the reason that I joined Apollo is that consideration. So my name is Jeff Hampton. I'm a salty, old tech engineer. I've been in the business 20 years or so. I survived corporate IT. I had a BlackBerry strapped to my underwear. Did some Microsoft SQL DBA work. And then, true story, got a couple of tattoos, got a MacBook. And then started doing web, and then React Native. Last few years, though, I had an opportunity to shift a little more to thinking about patterns, solid design principles, functional programming, which some of you may have strongly held opinions about, and functional reactive, which some of you may have even stronger opinions about. But generally, I'm a solutions architect here at Apollo because I like things that work. So today we're going to be talking about federation. And this talk is a spiritual successor to Matt's keynote this morning. He did a great job for teeing up this talk, so thank you, Matt. I appreciate that. I'm excited to cover the topic with you all today, but first, raise your hand. We're going to stretch for a second because it's 3 o'clock and we're tired. Raise your hand if you don't know what I'm talking about when I say federation. Raise both hands if you do know what I'm talking about when I say federation. OK, thank you all. I appreciate that. So what is federation? It is a declarative model for graph composition of loosely coupled downstream GraphQL services that enable static composition and validation of a unified graph using query plans to resolve downstream operations. That's tough. So instead, we're going to spend the next 20 minutes or so walking through each of these statements. And by the end, I promise this will not just be a bunch of jargon. Let's talk about what we're not covering really quickly. There are some great speakers here. I'm honored. This is my first time speaking. Last year, I was in the audience. I'm not talking about scaling or operationalizing. I'm not talking about Apollo's own journey moving from stitching to federation. Adam's going to be covering that tomorrow. It's a great talk. And I'm not going to cover every feature in detail. We're not going to cover heavy optimization. I really want to make sure that we all walk away with a firm understanding of the why and how of federation. So this is a talk in 3 parts. We're going to talk about motivation, the design, and the implementation of federation. So let's frame the problem. GraphQL is a great technology. We're all at a GraphQL conference, right? We're all excited about it. And it works for teams of all sizes, in all industries, all lines of business. I personally believe it's a transformative technology for teams and organizations. And once a team chooses GraphQL, it can spread from product to product and team to team pretty quickly. The velocity, the tooling. Now, Apollo heard a trend developing. As teams got excited about GraphQL and adoption increases, the graph can scale to a monolith, right? So the graph is getting larger and richer, but it can suffer from the same challenges that monolithic architectures have. Slower development, maybe more difficult tooling, causing friction among teams. Maybe you're sitting waiting for a PR for a long period of time. Right? So an obvious solution here is to break your graph into smaller pieces. There is a possible solution in schema stitching, and one that we used ourselves. Combining several graphs means that you'll need to ensure they can coexist. You might also need to namespace fields, because now you have type collisions. You might need to calculate some fields. I don't have a good place to put this logic. You might have runtime logic baked into the gateway to do all of this, and that runtime logic is going to end up costing you. It's harder to validate. There's a CPU cost. There's an integration cost. And ultimately, it's a brittle architecture, something that we discovered ourselves. We heard from our customers. So Apollo listened to her customers and got back to first principles. And if you have not read Principled GraphQL, I highly recommend it. I read it when I was at Sony, and I said, yes, right? Somebody sat down. I haven't read something like this since the Agile Manifesto. It's fantastic. Somebody has an opinion, and it seems pretty reasonable. In fact, it feels right to have a single graph for an organization and to have a federated implementation. So a principled implementation has important characteristics. And all of this principles and federation and architecture may have you wondering, is this for me? This sounds like we're going to dedicate a whole conference to it. Right? This sounds like hype. You aren't going to need it. Right? Yagni is you aren't going to need it. I learned that recently. Raise your hand if you have more than one graph today. Raise your hand if the graph that you have, you'd like to be able to refactor safely. Raise your hand if different parts of your graph have different security requirements, different performance characteristics, different CI/CD pipelines. Do you want to add more teams? Do you want to maintain their velocity? You can build a graph service by service. Adoption is incremental. And using federation and its design, the adoption is simple and straightforward. And I'll show you. I'm not afraid to do it on stage. It has good language support. Matt talked about this morning, but it's not just about this team prefers Java and that team prefers TypeScript. It's also, you have invested as a business in this team that does Java and this team that does JavaScript. And they all eat lunch together, they still get along, right? It's great. And there is a clear path to scale. And if adoption is that simple, and you can start today, then we won't have to have, when that scaling event comes, when that capital injection comes, when a new line of business opens up, planning today, implementation today will make that path clear for you. So if this all sounds good, how does it actually work? So the design of federation is different from schema stitching. It addresses scaling in a principled way, again. And there are some important characteristics. Remember this statement? A declarative model for graph composition. So what does that really mean? The federation specification is built on the same SDL that we all know and love. It is valid GraphQL syntax, which means you get all the benefits of GraphQL out of the box. Things like static composition, static validation. I can take these individual schemas, pull them all together, and revalidate that schema. Make sure that it actually will compose properly. Static composition means that as I push each individual schema and compose those things together, for those who are DevOps focused in the world, I can produce an artifact that I know is deployable and repeatedly deployable. And hopefully that means fewer PagerDuty notifications, right? That ahead of time processing also extends to things like perhaps optimizations of query plans ahead of time. I'm going to need to find a way to get to that service as quickly as possible. If I can analyze how my composed graph changes over time and what those individual tracing paths look like, I can now do analysis across the entire organization and optimize across the entire organization. Maybe I do move this service or this particular type from this service into that service because I'm geographically closer to the resource that I need. It's loosely coupled. So we're talking about separation of concerns. And as engineers, we tend to talk a lot about separation of concerns, and again, may have some strongly held opinions about those. And usually we're talking about isolating logic or co-locating functionality of some kind. And yes, federation does allow for this in multiple languages. But I believe that it goes farther. Separation of concerns extends to allowing teams to prioritize independence and collaboration over arbitrary constraints of process, PRs, waiting for those things. Organizations can focus on aligning human and machine resources instead of concentrating those resources based on technology and time constraints. In other words, I can't make those changes. The team that does the Java GraphQL server is busy, right? Federation allows for better and stronger architectural choices instead of making the concessions associated with a monolith or with schema stitching. Speaking of schema stitching, I think the hardest part of moving from schema stitching is to pull the logic back out of that gateway and put it back into the services and back into the team's hands where it belongs. Oop. And back up one. Let me back up two. Static composition and validation. It's just GraphQL, right? We're just using SDL primitives. We can statically compose. We're going to look at that in just a moment. This is all pretty sweet, but my favorite code is the stuff I didn't write that also has test coverage, right? The killer feature about federation isn't what is there. It's what is not there. It is not re-engineering client applications. It is not changing your tooling. It is not having a thick gateway that you need to scale independently that has variable CPU cost, right? It's just GraphQL to your consumers. That graph is going to look the same. We're going to see that in Playground in just a few minutes. Let's talk about the basics really quickly. It's one of the few, we're almost done with graphs, I promise. We're almost done. So first, each GraphQL service can extend another service, adding richness. So in this case, we have users defined in the account service, and I have some reviews. I really want the reviews team who knows how to query that database and add that information to the user, right? Once that happens, I need to compose that, make sure that it's valid, step 2. If you're using the Graph Manager, this is done in statically ahead of time. It is stored in a registry. That source list is stored, and we know that it's a valid and composed graph. Stop turning my head. And now, finally, the gateway is only concerned with planning the query and executing that operation. So implementation. In order to make this work, we're going to need a few things. We're going to need to reference types from other services, extend those types to add richness, and then be able to plan a query so that a given operation that's coming in, I know what services to talk to. I know what each of those services provides. So let's look back at this again. What I need is, on my user type, I need a way to identify it. And for those who have done a bit of database design, this should look fairly familiar. I need to define a key. It's an algebraic way to identify that particular entity within the graph. Now that I have an entity, I can extend that entity with additional information. Keynote is starting to be difficult. I'm just going to use my finger. So in the review service, I can add my reviews to the user entity. There's a little extra syntax there. We're going to cover that in a demonstration. But once this is all composed together, what does it actually look like? When you view this schema in Playground, it is a single unified graph. So we now have our single unified graph that is federated in implementation. What about that query plan? Let's say that we have this operation with the same schema that we've been talking about. So I'm going to look up me. I have some kind of token. I need a name, username, and I'm going to go grab those reviews. So send that off to the gateway. The gateway knows, well, the me query and the user type, that entity is defined over in the account service. Let me go fetch that first. Once that comes back, you can take that user, pass it to the review service. The user says, the review service, says, thank you for the user. Let me give you back some reviews. And at that point, it's just recombining each of those objects, serializing it, and sending it out the door. Demo time. And I have paper notes because I'm a salty old engineer. Let's start here. Can you all see in the back? Raise your hand if you cannot. 1. I'll give you one more bump up. Let's do the same thing quickly. This is Playground. Is it OK? OK. So let's take a look at that user entity again. This is what I've shown you a few times now. That key syntax, for those who aren't doing federation today, should start to feel a little less strange. Key directive is simply defining the field that I'm going to use to identify that user. And in fact, let's talk to just the account service itself. So each of these services is a bona fide GraphQL service. So I can execute this operation. I promise this is real. Here, look, I'll refresh it. There we go. OK, so that's just the account service. Let's go back. And let's take a look at review quickly. So I need to define a review entity. Again, I need some way to locate that entity within the graph. So now I have a key. I'm using ID again, not creative. The body of that review. And now you notice that I'm going to reference back to the user. So because I know that a user entity exists within my graph, it was defined in the account service, now I can reference that here and include it. We're going to see what happens when you begin to have what appear to be circular references here in just a moment. But more importantly, my review service is concerned with providing reviews. So here, I can extend the user type. I match that signature. So now the review service knows that there is a user and that these things exist external to this service. And then says, OK, great. When you're looking for reviews, I've got you. I know exactly what to do. So let's look at the user service. I have a single review. The body says, love it. They like that one. Now, what's going to happen if we have author? I actually have an ID there. Can I add username? I can. So in this somewhat contrived example, but real example, the review service does know that a given user ID and a given username provided that review, right? The review service is concerned with capturing that information. Now, the account service has the full-blown user. They've got billing information and all that other stuff, let's say. But in my review service, I actually know about just little tiny pieces of a user. And then sure enough, I can actually show here that I have an author, and I can provide username. I know how to do that. It's going to save me a round trip here in a second. So I'd shown you a static version of this before, but let's look at the full-blown schema now. There's my user type. There's no fancy entity syntax. There's nothing that would break a client. That iOS app that you released last year that you're still waiting for approval to update after iOS 13. That thing's not going to break. You've added reviews onto this type, for instance, but the federated graph is not going to break those clients that are out in the field. I can see that there's a username. I see the review type, and it knows that there's an author that refers to the user. I've got a few others. There are 2 other services participating here. So let's start to execute some queries, and let's see a query plan. Now, for those who have used the experimental query plan, I hacked in something different for today. Because I'm old, and I like diagrams, and I was tired of reading JSON by hand. So first things first, let's see what happens when we ask the gateway. When I go to fetch me, what are you going to go do? Well, I'm going to go to the account service. I'm going to go fetch me. It's pretty straightforward. Now let's go ahead and make sure this is valid syntax. I want the review associated with that user, reviews. So now I know I have a sequence of operations I'm going to need to perform. I'm going to go to the account service. I'm going to fetch the me portion of that query. I'm going to collect the result of that query. I'm going to use it as input and fetch from the review service. Pretty sweet. I want to go ahead and pull author. And remember that username, I had an optimization. I actually can provide username from the review service. So this doesn't look any different. The plan itself doesn't look any different. The result now includes username. But the query plan, sequence. Go and fetch my account, collect me, return my reviews. And what happens if we add in name? Because review doesn't actually know about name. I'm going to go fetch my accounts, collect the value, fetch my reviews, and for each one of those reviews, I need to resolve author. I'm going to use that as an input back to the account service, and then it will go and fetch the name for each one of those. You might want to talk to the reviews team and see if they want to store that over there, or maybe don't include that on the UI. Because really, all we really needed for the reviews is we just need to show the username, and then we'll link to their user profile, right? I've saved myself a hop here. I don't have to go back to the account service. It's pretty handy. So I also have some products. And in this particular example, the product service has a furniture implementation. So product is an interface, and there's a furniture concrete implementation there. In fact, let's look quickly at what this is actually going to look like. So I do have tables, couches, chairs, and apparently books. So let's go ahead and see what happens now when I say, OK, for each one of those reviews, what product is that about? Not able to resolve. There is no product on review. Told you I wasn't afraid to run this demo. Let's see. I know that I have a review entity. Oh, right. Silly me. Let's make sure it composes. Remember static composition? When the gateway starts up, it actually can tell me whether or not that's there. I have a query plan. Same sequence as before. I'm going to go ahead and collect me. I'm going to fetch the reviews. I'm going to take the reviews and the product. I'm going to go fetch my products, so I know what that is. Now, these have all been serial operations. And you might be wondering, is every operation that I ever send going to be some serial nightmare where by the time I get to the very end, the client has timed out? The answer is no. Oops. I don't need the definition of book. So if you're going to clap at building a dynamic query plan visualizer in the last couple of days, now would be the time. Just telling you. I'm not too proud to ask for that sort of thing these days. The query planner is smart enough today already to understand that I'm going to go ahead and fetch these reviews, and for each one of these reviews, I can actually hit two different services in parallel. One of the services is concerned with returning the furniture concrete type implementation, but since the book service also is a product, I can go ahead and fetch those in parallel, and I can do that because what I need to do that is the review, because the review has the connection to the entity. That is the product. Once I make this prettier, I'll go ahead and submit a PR. So for those of you who do use the query planner on a regular basis, I promise I'm not trying to keep it for myself. So what is the architecture of federation? What is federation? It's a declarative model for graph composition of loosely coupled downstream GraphQL services that enable static composition and validation of a unified graph using query plans to resolve downstream operations. I hope this makes a lot more sense now. Because when I was building this talk, I started with this, and then I worked through my demo, and then it made a lot more sense then, too. Again, thank you. Thank you for being here. Find me on Twitter. Find me on GitHub. Find me here. I'll be around. I'd love to talk to you about all things architecture, code, if you're into that sort of thing. We have some feedback forms in the back. And I will see you all on the internet. Thank you so much.